Hey guys, and welcome back to another video. Today we're going to be going through sets 12 to 13, which is equations. Before we begin, let's explain what an equation is. An equation is an expression which relates two values to each other using the equal sign, meaning this x plus 5 is equal to 12. Now, this equation is an example of an algebraic equation, which is an equation which has a variable. So in this case, x is our variable, and a variable is just a number which we don't know the value of. So the main idea in algebra is we want to isolate our variable onto one side of the equation so that we can find its value. One way we can solve algebraic equations is using something called inverse operations or opposite operations. So our four main operations in math are plus, minus, times, and divide. And the inverse of each operation is the thing that does the opposite to the operation. So for example, adding and subtracting are inverse operations, because if we add 5 and then take away 5, that cancels itself out and we just get 0. And multiplying and dividing are also inverse operations, because if we divide by 3 and then times by 3, that does nothing. We just get our original number. So how can inverse operations be used in equations? Well, we can essentially get rid of certain numbers so that from one side of the equation in order to isolate x using our inverse operations. And we'll look at how to do that in a bit. Firstly, we're going to be going through some examples to get us a little bit more comfortable with inverse operations. So here we're not working with equations just yet. Here we're just going to be working with some algebraic expressions, and what they want us to do is to get x by itself in the expression. So looking at this first example, how we can get x by itself is we can get rid of the plus 7 from the expression. So how we can do that is use the inverse of adding 7, which means we take away 7 from the expression, leaving us with just x, because these two cancel each other out. Simple, right? Well, this expression is a little bit harder to simplify, since we have both a plus and a fraction, which is the same as division. So looking at this expression, we can see that the x plus 4 is divided by 3. So what we want to do first is we want to multiply the whole expression by 3, which gets rid of the divide by 3, as division and multiplication are inverse operations. That leaves us with x plus 4, which, as you can see, is very similar to what we did in question 1. So we can just minus 4 from the expression, leaving us with just x. That's pretty simple, and you have answers to all of these questions anyways. So if you have any trouble, just ask your teacher in class. Next, moving on to solving equations using inverse operations. So like I said before, the main idea and the main reason we use inverse operations is to isolate the unknown value or the variable from the known values in an equation in order to find the value of the unknown variable. Now, one thing to keep in mind is when we're doing inverse operations, you must make sure that whatever operation you do to one side of the equation, you have to do the exact same operation on the other side, because otherwise your two sides of your equation won't be equal anymore, because this means both sides of the equation have to be equal, which means equal operations have to be done on both sides. So looking at this example, x plus 9 equals 30. What we want to do to isolate the x is we want to get rid of the plus 9. So what they've done is they've minus 9 from both sides of the equation, leaving us with x equals 21. So that's pretty simple. Again, we have some examples with pretty detailed working out. So hopefully you can understand that bit. And again, if you don't understand, make sure to ask your teacher in class. Moving on to some more complicated examples. Here, we've got m multiplied by 6 minus 10. So here you're going to have to do two inverse operations to get your answer. The first thing you want to do is get rid of the negative 10. So what we can do is add 10 to both sides of the equation, giving us 6m equals 30. Next, we can divide both sides by m, which will give divide both sides by 6, which will give us m equals 5. So again, we do have some pretty detailed working out here as well and explanations. Next, moving on to equations involving brackets. So generally, when you have a bracket in your equation, the first thing you want to do is you want to expand the brackets. So as you can see here, what they've done is they multiplied 3 by x and then multiplied 3 by negative 5, leaving us with 3x minus 15 equals 24. Right. Next, they've added 15 to both sides of the equation, giving us 3x equals 39, and then they've divided 3 on both sides, giving us x equals 13. Another way you could have solved this equation is instead of expanding first, you could have divided both sides of your equation by 3 first, which would give you x minus 5 equals 8, and then you could add 5 to both sides, which gives us x equals 13. So as you can see, that gave us the same answer, but we just did our inverse operations in a different order. So there are various different ways you can do the order of your inverse operations as long as it's correct. Again, moving on to this equation, as you can see, what they've done is they've expanded our brackets, giving us this expression. Here, what they've done is they've decided to add 4 to both sides of the equation. So, as you can see, both sides of the equation have a term with the variable and a term without the variable. So, we want to move the terms with the variable onto one side and the terms without the variable on the other side. And what they've done here is they've decided to cancel out the minus 4 on this side of the equation. So they've added 4, which cancels out the minus 4, giving us 10a plus 9 equals 12. Then they've decided to cancel out the 10a on the left side, and leaving us with 9 equals 2a. Then they've divided both sides by 2, leaving us with a equals 4.5. Now, generally, when you're solving algebraic equations, especially in VCE, they'll want you to give the answer in a normal fraction, not a mixed fraction like they've given here. So I would like everyone to give your answer in a regular fraction when you're giving an answer to an algebraic equation. Also, keep in mind is that you always want to give your fraction in its simplest form. So instead of something like 18 divided by 4, you would always have 9 divided by 2 as your answer. Otherwise, you will lose marks. Moving on to equations with fractions. So whenever you have an equation with a fraction, you want to multiply both sides by the lowest common denominator to get rid of the fraction. So looking at the first example, This one's pretty simple. They've just multiplied both sides by 5, giving us 3x equals 35, and x equals 11 2/3. Looking at this example here, the lowest common denominator of 3 and 4 is 12. So they've multiplied a 12 on both sides of the equation, giving us this expression, which is very similar to this question. So you do the same process from this question up here to solve this expression here. So I'm not going to be going through that again. Also keep in mind is that sometimes you don't always multiply to get rid of the fraction first. So if we have something like 3x over 5 minus 5 equals 7, if you multiplied both sides of the equation by 5 first, you would get 3x minus 25 equals 7. Which is still okay, but it might be easier for you to, instead of multiplying by 5 first, it might be easier for you to add 5 to both sides of the equation, as you would be getting rid of the negative 5 here. Alright, moving on to checking your answer. Oh, sorry. So, how you can check if your answer to an algebraic equation is correct is you can sub in your value for x back into the original equation. So, if I were to do that with this equation, I would sub in negative 6, which they say is the answer here. So that would give me 3 times negative 6 minus 5 equals 7 times negative 6 plus 19. So that would be negative 18 minus 5 equals negative 42 plus 19. So that means negative 23 equals negative 23. So as we can see, both sides of the equation are equal. So the equation is correct, meaning the value we found for x is the correct value. If we found the wrong value, the two numbers on either side of the equation would be not equal. So we know we've done something wrong there, since the equal sign means these two must be equal. So that's how you check your answer. Now moving on to inequalities. So when you're dealing with inequalities, you generally treat them in a similar way to how you would treat your equal signs in expressions, in equations. However, there's one main difference, and that main difference is that when you multiply or divide both sides by a negative number, you have to flip the inequality. So if you had a greater than sign, if you were to multiply or divide both sides by a negative number, that greater than would become less than. Also, if you're not familiar with these signs, this is a greater or equal to than sign, which means if you had 3 greater or equal to, x, if you had x greater or equal to than 3, that means x could equal 3 or any number larger than 3. Whereas if you had x greater than 3, x would not be able to equal 3, but it could be equal to any number greater than 3. So that's the difference. Looking at this example here, you can see that the first thing they did was they took away 1 from both sides. Next, they divide both sides by negative 3, and they get the answer x less than negative 2. And when they've divided by negative 3, as you can see, the sign of the inequality changes. So make sure when you're doing inequalities, you keep in mind that your sign is pointing in the right direction. And the last thing we're going to be going through is the number line. So the number line is just a way you can represent inequalities. And the difference between how we represent our greater and equal to and less than or equal to compared to our regular greater than or less than is for greater than or equal to, we use a dot, a solid dot on our number line, and for these ones we use a open circle or a not shaded in dot. So as you can see here, for number 1, x greater than 2, we've got a open dot on the 2 and then a line pointing upwards. So this means that the expression represents any number greater than 2 but not including 2. Whereas for this one, x less than or equal to -3, as you can see, they've got a shaded in dot, which means this number line represents every number smaller than 3, including the smaller than -3, including the number -3 itself. Finally, let's go through an example of inequalities on a number line. So first, we'll go, sorry, 1 second. Yep, so we'll go through this example here. The first thing they've done is they've multiplied both sides by 5, as that way they can get rid of the 5 in this fraction. Next, they've taken away 1, giving us this expression, and finally they've divided both sides by -2. And again, as you can see, the sign of your inequality has changed when you've divided by -2. So same thing with multiplying by -2 as well. You have to make sure that your sign is pointing in the right direction. Then they've represented this expression on a number line. As you can see, there's an open circle above the -7, which means it does not include the value -7, and then a line pointing upwards, or upwards in the number line, showing that m is greater than -7. Alright, and that's all the content for set 12 and 13. If you have any further questions, please make sure to ask your teachers. In the next video, we'll just be going through some of the example questions. Alright, bye.